back to my turn, or? Okay.
I think so.
I'll go ahead and say it.
Okay.
Our dear Heavenly Father, we're grateful that we can meet together as a group to learn from one another and share and bounce ideas off of each other. We're grateful that we have the opportunity to take these online courses and to better our education. We're grateful for our friends and for the opportunities that we have. Please help us to understand the material that we're going to cover tonight and to be able to help one another. And we say these things in the name of Jesus Christ. Amen.
Amen.
Thank you.
All right.
So, did someone say they wanted to go over part 2?
No, I thought that's what we were supposed to do, is go over part 2.
Part 2.
If there's a...
Well, let's see. We've got...
But they kind of do that in that video too, though.
Yeah. The last video kind of goes over the homework.
Right.
Mhm.
And understanding. Okay, so I don't know. Do you guys want to go over any of the material that? Did you have any questions on the material? Well, I know you do, Zach, because you don't have it. So
Well, I finished it. I just don't have it.
you're just gonna have to write everything down, huh? Okay.
Yeah. I'm pulling up the PowerPoint though from today's lesson.
Okay.
So at least I won't be completely uninformed. It's just a bummer for me because like the way I do it, like I highlight what different things are with a highlighter marker. So for me, like I grasp it quicker because like my mean is always highlighted in yellow in the question and then matched down below in the equation, and then my standard deviation is always green, and I don't know, it makes more sense to me. It's just
That's a good idea. You thought of that.
it's all good.
Okay, so one of the questions, and we're going to have it on the quiz, so might as well see if we can figure it out. When you're taking the sample size of 100, okay, and what's the shape of the distribution? It's if the population is right skewed, would it still be right skewed?
Wouldn't it be like a normal?
Well, that's what I'm wondering, is because you've got a larger, when you're taking a large sample size, even if the parent population is right skewed, does that automatically shift it back to normal?
I think it does. That's what I would say.
That's
At
what I
least-
understood.
Because I
Yeah,
know
I'll say
it says in the book.
according to everything we did today, it was.
Okay, because they say if it's like the n is 5, then that's normal. But if the parent population is heavily skewed, oh, I see. Then it just requires a larger sample for it to become normal. Okay.
Yeah, and I think I remember, didn't it say in the reading that if it's super skewed, it could need a really huge number, but for the purposes of the problems that we do, we are going to, it says that we need at least 30. I think it said something like that.
Okay, I thought I remembered reading something about that, about like 1 billion samples or something.
Oh wow.
Needed a
See if I
lot.
can find
I
it.
don't know about 1 billion.
Let's see.
Okay, yeah, it actually does say that. It says,
Yeah, it says this may require billions of observations, so if it's heavily skewed.
but
Okay.
it says, for this course, if the sample size is at least 30, we will conclude the sampling of the distribution of X will be approximately normal.
Okay.
So in real life, yes, but for our situation, we just need 30.
And like they said in the reading, in real life, you would only be able to see your own observation.
Yeah.
So we wouldn't have to worry about everything else.
Oh, and the quiz has a normal probability applet in case we need it.
Right. We used that today during the lesson, wasn't it? Or was that something else? Like when we were reading the reading material, remember how we had to go to that website and do all those steps?
No, it's got that the applet like we used last time.
Oh,
When you
okay.
first start the quiz.
Yeah.
Gotcha.
So if we are using that, the N, the size of N would go in the area. Is that where we're putting that? I'm not sure exactly where to put that. Hang on one second, guys. Be right back. Hey, hon, sorry. You okay? Sure. Sure. What? No, I didn't see it in the front yard. Okay, let me play it back. Okay.
So on 3, did you guys say it's skewed right? With the sampling size only being 5?
I've lost you guys. Hang on.
That was question 3. If N
I think
was
so
5,
because it said it needed 30 in order to be considered
at least
normal.
30, right?
So if it's
Right.
only 5, then yeah.
Sorry, guys. I lost you. So for 3, did you get, what'd you get,
So
normal?
where N's 100 and now it's going to be normal.
So
For
for
3,
3 we got skewed right.
yeah,
You did.
And then 4 is normal.
yes, 4 is normal.
Oh, I see. Right skewed. Okay, and then normal. Okay. Yeah, okay. I got you.
And then so 5 would probably go normal again if it's the
If it-
parent population is normal.
Yeah, because that's what I read for number 3 is that it was normal. I missed the right skewed. I've got to read more carefully.
Yeah,
Yeah.
I would say 5 is normal, isn't it?
Yeah,
Because of
yeah. It
what
says if
is
the
it?
parent
The
population.
central limit theorem.
Yeah, it says if the population is almost normal, then N equals 5 will probably be sufficient to assure that X will be approximately normally distributed. I'm sorry, I don't use the proper terms for these symbols.
No, you're fine.
I don't have my
I've always had a very
in front of me, so it's an X and O. And
no, I've always had a very terrible math vocabulary. That's part of why I never got it all these years.
I gotta work on that.
Like I know they're talking English, but I don't understand what they're asking me for.
Aren't the symbols Greek?
Yeah.
They are.
They're not even speaking English.
Okay, so for number 6, if you're taking the sample size of 100, what's the shape of the distributions of mean histogram when the parent population is normally distributed? Wouldn't that be normally distributed?
I believe so.
That's
I'd go
what I
with
think
normal too.
I think it kind of follows, doesn't it, just a little bit?
Right.
If it's big enough, which we consider that big enough. Okay. Number 7.
When would the distribution of means be normally distributed? Choose all the correct responses. Data are drawn from a population that is normally distributed, and the sample size is small. Data are drawn from the population that is normally distributed, and the sample size is large. Data is drawn from a population that is right skewed, and the sample size is small. And data is skewed from a population that is right skewed, and the sample size is large.
It says in the book there are 2 ways that it can be normally distributed, and they are X will be normally distributed if the data were drawn from a normal population. So that has to be the first one, right?
Yeah, so then it has to be 1, 2, and 3 then.
Because there's a couple answers in there.
And then X will be approximately normal normally distributed, the sample size is sufficiently large. That's number 2, right? There's gotta be another answer there.
Yeah. And then
Yeah.
if it's not normal, it needs to be big. So then it'd be 1, 2, and 3, I believe. Or 1, 2, and 4. Sorry.
Yeah, I was gonna say so.
1, 2, and 4.
The other ones that isn't is the right skewed and small sample size.
Yeah, I think you're
Okay.
correct.
Which of the following gives the best explanation of central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution. For
Yeah.
bell-shaped data,
Okay, go ahead.
for bell-shaped data, approximately 68% of the data will fall within one standard deviation of the mean. Yada yada yada. Sorry, I don't see any point in reading all that when we know the rule.
Sorry.
If the sample size is large, the sample mean will be close to the population mean. If the sample size is large, the shape of the distribution of sample means will be approximately normal. I wanted to say that it was the first one,
Well,
but
I don't think
let
so.
me go back and just double check.
the slide says as the sample size n increases and becomes large, the distribution of sample means become approximately normal.
Okay,
But
so
is that
then
1 and 4 correct?
We only can choose one.
Yeah, we can.
Definitely on 1.
Oh, choose one. It's not, I don't think it's one, is it?
Yeah, it's like they're both correct.
But yeah, because they both
Only
follow
use-
the rule. I just don't know which one's the better.
right,
In
which
our-
one is more correct? The one they're
in
looking
our-
for.
In our notes on the key points, it said central limit theorem, as the sample size n increases and becomes large in quotes, the distribution of sample means becomes approximately normal. So I think that last one would more closely tie to that.
Okay.
I don't know. I think they're both right too, but
No, let's go with it. We have another chance, so it doesn't matter. If it's not one, it's the other.
So what are we saying? It's the fourth one?
Yeah.
fourth. And the one before that, did we go with just 2 and 4, or was it 1, 2, 4?
1, 2, 4.
1, 2, 4.
1, 2, 4?
Yes.
Yeah.
Okay. So number 9. Let x be a random variable with the population mean equal 10, population standard deviation equal 6, and a sample size n equal 36. Oh, what is the mean of the distribution of sample mean? Isn't that like isn't that like 10? Or do we have to do a fancy equation?
It's not fancy. It's just what we did. Like if you go back to the slides and see what we went over today. I believe it is just your, where you take your mean and then
Subtract.
No. Sorry. You take your standard deviation, and you divide it over.
Divided by the square
whatever.
root of n?
Yes. I think that's what it is, isn't it?
Yeah, we have to take our standard deviation and divide it by the square root of n.
Okay, so
So that would be 6 divided by the square root of n. which
I
is
believe
6.
Doesn't that come out as just one whole?
Yeah, that's what I'm getting.
Yep.
You get 1?
Yeah.
Yep.
6 divided by the square root of.
Of 36, right?
Yep. It's not some fancy way we have to enter this in, is it? We just can put a 1 and save. We have to like.
I hope so. I know we start questioning everything, don't we? It's like, did I put it in right? Did I put the decimal in the right place?
Just
You want a
every
percentage
semester.
this time?
Every semester, I always end up entering something in a wrong way, so I'm a little gun shy always when it comes to putting an answer in with math.
Okay, so what's the standard deviation of the sample means?
The
6?
standard deviation of the sample means. Are we still using the information from above?
Looks like it.
Yeah.
Yes.
Then wouldn't it just be 6? That's the standard deviation. Oh, wait.
The U of X
Um,
is U.
let me see there.
The
Standard
mean of the
deviation.
distribution of sample mean equals the mean of the parent population.
Deviation of 2.2. Standard deviation of 6. So what did you guys get?
Isn't
Is it that simple?
well, I'm wondering if the first one, the mean of the distribution of the sample mean, is really the 10, and then the standard deviation of the distribution of the sample is really number 1. I think the first one's 10, and the second one is actually 1.
What is the mean? Yeah.
We've got a
Yeah,
problem.
you're right. You're
Yeah.
right.
Yeah, I think you're right.
Reverse it, right?
You're totally right.
Yeah, the first one is 10, and then number 9 is 10 because it's looking for the mean, and then 10 is 1 because it's looking for that sample standard deviation.
Yeah, like the
distribution.
sample in
Good
our
call. Nice catch.
All right. Oh, that would be normal.
Okay, yeah.
I think.
Regardless of the distribution of the population, if the sample size is large, what would be the shape of the distribution of the sample means? Wouldn't it be, if it's large enough, wouldn't it be normal?
That's
Yeah.
I'm
exactly
going with
what I would
normal.
say.
Yeah, I would say normal.
No, great. Explain it.
What theorem would justify your response?
Okay, so that would be wouldn't that be the central limit theorem? Because it says the central, let's just do CLT states that if the sample size is large, that X will be approximately normal. The law of large numbers states that the sample means X will be close to that other funny little sign.
Yeah.
I'm going with that. Yes,
We're going with
that was my
CLT.
answer.
Mm-hmm.
Right.
Okay.
We're all supposed to hit submit.
Yeah, I think they want us to submit it all together.
Yeah.
Well, here goes nothing.
All right. 100%, guys.
All right.
I think that's a first for us, isn't it?
I don't even remember. Is that
Woo!
bad?
Which one?
Oh, I didn't remember if 100% was a first for us.
I don't think we all do.
I don't know. I don't.
No, I think we did that before.
Yeah, I think so too.
Yeah.
Did anybody look
All right,
at the
good job.
homework yet?
Did any of us what?
Look at your homework yet?
No, I haven't.
No, I haven't.
It looks
I
like
didn't
it's
see
pretty
it.
much the same thing as the questions we just answered.
Awesome.
Oh, nice.
So
Very nice.
it should be fairly simple.
Awesome.
I'm good. How
Sounds
about you?
I'm good.
All right.
So am I.
I gotta find another way
Thanks,
to do
guys.
this so you guys aren't looking at the side of my head the whole time. Because I'm
Oh, you're
either over here
I
and
got
I'm up on my screen. I can only use one or the other. So, alrighty. Well, good luck, Zach. Hope you find all your homework.
No, I do. I know exactly where it is. It's sitting on my keyboard. So it works. But
All right.
thanks, guys. I appreciate
Yeah.
all the help.
Thanks, Zach.
Thank you.
All right. Have a great night, guys.
Bye, Maria.
We'll see ya.
Yeah.
Bye.
Bye.